Okay, perhaps this was a jump for you guys, but I didn't think so. I think you had the tools, but it was a challenge for some of you. Here we go. It doesn't really give you much here, so the end in mind says the best fit mathematical model here is an equation you're looking for, and you want it in standard form. Again, that last part, write it in standard form, was meant to give you the opportunity to enter it in a decreasing order so that it looked like it would be recognized. Okay? Best fit. Best fit, in your notes, probably should be another word for regression. So you're going to do a regression here. That's the direction that should have mentioned to you, and or came to you as a result of that best fit. Now this that meant we know how to do regression for ax plus b. We know how to do regression for ax squared plus bx plus c. Linear and quadratic. That's what we've studied so far. Now, what have we discussed as our tool for deciding, or tools for deciding that which is better? Is linear better or is quadratic better?
Quadratic.
Okay, well, what are our tools? How do we know which is?
I'd plug them both into Desmos and then see which are squared or closer to
Okay, so let me add this one first. There's a visual. So when you do the dots, the scatter plot, and you look at it, you can see which one looks better. Now I'm going to add to this, there is a dependency here on your, I'm going to call it your viewing window. If you look at this in a very small window, it looks like a straight line. If you widen it out and use that little magnifying glass that Sarah's taught us about, it makes it look more curved. So visual is a good indicator, but maybe not the only indicator. All right? Clarissa says to use r squared. For an imaginary bonus point, what's the name of r squared? It was on the first test, and nobody seemed to remember what it was. Very close. It is the coefficient of Hadley, every time you move your head and I see your hair flop, I think somebody's holding their hand up. Isn't that weird? Okay, yeah, Jalen, I thought it was you. Okay, it's not correlation. Correlation tells us how strong a straight line it is. Determination. Okay? So we can use the coefficient of determination to decide. Okay? And that means that the closer to 1, the better the fit. So this problem is in place so that you would take and try both, and you would find out that linear comes out to be about a 0.98, I think, but this one comes out to be like 993. So quadratic becomes the one to do. You can do the first one. If you only did linear and saw 0.98, you likely stopped and said, that's really close, I'm good to go. And that puts you, that's a good fit, but it's not the best fit. So then you have to enter it, which I think we did an okay job of getting the word out that you had to put x caret 2 plus 181.4x plus 4218.78. So this one wanted you to find regression, then it wanted you, and if you're using Desmos, Joey, another pitch for Desmos, You could quickly do both and see both right there on your screen and see both our squared values and see the curve better. It's just a quicker way. Take 10, 15 seconds and put in what you need.